and Physiology. Yeah, I'm right here for you guys. Before I actually go any further, today we are looking at what we call the musculoskeletal system. Musculoskeletal system. That means we're supposed to look at two systems at once. But for this part one, I only actually depend much on our skeletal system. And you must appreciate that the skeletal system is one of the rigid framework of different bones that actually give shape to the body. You must appreciate that today we are going to look at what we call the skeletal system. Today I'm going to dwell much on the skeletal system. I want you guys to actually come in online to actually invite your friends so that we can enjoy this discussion. And for this discussion, actually much as seen in what we call diagrams. We must discuss a lot of diagrams here. And you must appreciate that skeleton, as I've actually, before I even go any further, I always told the skeletal system, we shall actually have to look at the course outline here. It actually starts with the bones. Look at the functions of the bones. We shall look at the types of bones. We shall look at the structure of a bone. We shall look at the microscopic structure of a bone. We shall also look at the development of a bone. And we shall also look at the bone markings, the bone healing, the healing of a bone. And later, in the long run, we shall look at what we call the skeleton. And we shall appreciate that the skeleton is divided into two. That is the axial skeleton and the appendicular skeleton, where we shall see much and we shall understand everything with time. We shall also look at the joints. We shall look at the fibrous joints, the cartilage joints, the synovial joints. We shall also look at what we call the main areas. We look at the synovial joints. We shall go deep into the synovial joints and enjoy this topic. We shall also look at what we call, with the long run, we shall also look at the principal muscles that are actually found on the different bones. That is in the muscular system. But today, I will actually drill much on what we call skeletal system. And you must all know, by the time I finish this skeletal system, you must be able to answer the following questions. By the time we finish, we shall only have a discussion for an hour. We must be able to actually give the functions of bones. You must always give the types of bones and give the examples. You must be able to give the general structures of long bones. You must also describe what we call a compact and a spongy bone. You must also describe the development of a bone. You must also explain the process of bone healing. You must also actually identify the factors that lead to delay of bone healing. You must also describe two complications of fractures, and you must also actually outline the factors that determine your bone growth. So, by the time I will end this, the course unit, you must be able to do everything about what you call the skeletal system. Allow me to tell you that skeletal system is to do with only the skeleton, cartilage, ligaments, and the tendons. When I talk of skeleton, I mean the framework of bones. When I talk of the cartilage, I mean those soft bones found in your ears. The soft bones that actually can tilt. When I talk of the ligaments, I mean those areas that have to join actually what we call a bone to bone. When I talk of the tendon, I mean those are actually a structure that join a bone to a muscle. We shall see that more in muscular system. Allow me, if I proceed, I'll actually allow me to tell you that the skeleton is a rigid framework of connected bones that gives form to the body. You must appreciate any framework of bones, any combination of different bones will always give shape to the body is what we call a skeleton. And you must appreciate that a human skeleton is actually composed of 206 bones. 206 bones. Did you know that? That your body is composed of 206 bones? You must know that your body is composed of 206 bones. It is also composed of what we call the ligaments. cartilage, tendons, and different joints. All together give us what we call a skeleton. Allow me right away answer the first question I actually told you, which is the functions of bones. And among the functions of bones, you must appreciate that it gives framework to the body. The first function, provision of framework to the body. With framework, you mean the shape. The reason as to why you see me as the way I am because of the presence of different bones here. They give this. So, because of my skull being this shape and this size, bones always give to muscles with muscles and tendons. You must appreciate that as we shall be looking at your muscles, we shall start a tendon, joins the bone with muscle. So hence the attachment we are talking about. It was actually movement of body, as movement of the body. Yeah, as a function of different bones. It also actually forms boundaries of different cavities of the body. You must know that your body is made up of almost 4 cavities. That the cranial cavity is this cavity running from the upper neck to the upper root of the neck. From the upper head to the upper root of the neck is the cranial cavity, where we have the brain. From the upper head to the diaphragm, we have the thoracic cavity. From the diaphragm here to in between the pubic bone. And when I talk of the pubic bone, I mean that bone that has got the pubic hair on the private part. That is the bone we are talking of. It is what we call the abdomen cavity. So, all the abdominal cavity. So, from the pubic bone going down to the limbs, we shall see what we call the pelvic cavity. Whenever I discuss the system, I also happy. It's actually a very simple topic, which actually just requires around 1 hour for you to understand. As long as you understand bone healing, you understand bone development, you understand the types of joints we have, you understand the skeleton in 2 types, you enjoy the topic. Allow me to continue the functions of bones. First of all, I told you, actually it helps in the framework, and hence giving shape. I told you it helps in attachment of muscle to tendons. I later told you it forms boundaries of different cavities. Now, allow me to tell you that it helps in the production of different cells. Through the process I told you, yesterday I must have discussed for you blood. And with the blood I told you, it's called hema. Actually, it is a process where body cells are made in the body. So what we call hemopoiesis. Hemopoiesis is that process by which we form different cells. So different bones help in that because they have the bone marrows. Bone marrows will help in that. Allow me to tell you that actually bones actually sources of different minerals in the body. We have the calcium being stored in the bones. Have the phosphate, or actually almost electrolytes are stored in the bones. Yeah, as a medical worker, you must appreciate that skeleton is very important to you as a person because it keeps for us those different sorts. A lot of functions actually actually for the skeleton are given. You must appreciate that also still the skeleton actually helps in protection of different delicate parts of all different organs of the body, like the heart, by the rib cage. Are we together? The brain is protected by what we call the skull. Are we together? So, having understood the different functions of the bones, allow me continue and actually proceed. Do you have people online? They are not, eh? No problem. No problem. They will come. Allow me continue, and I look at the different types of bones. When I look at the different types of bones, we shall appreciate that bones are actually divided majorly into what we call the long and the short bones. Those are the major types. But we have also got other types, which include the regular flat and the sesamoid bones. When I talk about the long bones, these are actually, this consists of a shaft and at the two ends. And we shall see when we shall be actually looking at the structures of bones that those shafts are given names. We shall see that the upper shaft and the lower shaft, you shall realize that as bones, if you have ever eaten chicken, bones are supposed to go that half and so another half down. Those halves are the shafts, and we appreciate that the upper calf is what we call the epimysium, and the middle calf is what we call the dimysium. All together. So depends on the area you come from. I told you the pronunciation of different anatomical terms depend on the areas you come from. Allow me actually tell you that long bones actually have two ends. That is the epimysium, one at the up and one at the bottom. So and you must appreciate that among the long bones we have what we call the femur, found on the thigh. I have with the tibia, also have what we call the fibula. That's some of the examples of the long bones. And among the examples of the short bones, you have what we call carpos. These carpos here, these carpos. Under the waist, the carpos. Those are what we call these carpos. What we call the short bones. And you must appreciate that we also have what we call an example of the regular bones of the what we call the vertebral column. With the vertebral column, we mean the spinal cord or the backbone. You must have it is irregular in nature. We also have what we call flat bones. And the flat bones, the example, the basic example what we call the sternum. We also have ribs, they are flat in nature. We also have other bones like the skull bone. With the sesamoid bone, you must appreciate that you have the patella. The patella is that part found in your knee. That bone that rotates, what called the patella. So, having understood that those are the types of bones we have the short, long, flat, and sesamoid. Types of bones we have. So, allow me to continue and also look at the different components of bones. When I talk about components, it means what of the bones. We have a component 25%. Did you know that? We have water in the bones. We have the inorganic substances, especially the calcium, the phosphates, the sodium, and other nutrients that are found as inorganic substances, the bones. We also have what we call the organic substances, including carbon, that is in the formation of the matrix, that space that is found in bones. We also have what we call the bone cells. So, you must appreciate that the bone is actually divided, dividing structures and tissues with blood supply. You will see that the bone, any bone in your body has got blood supply. Same to any other system we have always been talking of. The heart has got, and the cardiovascular has got actually blood supply. The digestive system, blood supply. Muscular blood supply, skeletal blood supply, lymphatic blood supply, and so many other systems that are actually seen in the other semesters. Yeah, allow me actually continue and look at the structures of the different bones. When we look at the bone, allow me look at the structure of the bone, and I must appreciate that. Allow me actually bring this to your attention that a bone actually looks like this. You must appreciate that a bone has actually got what we call a shaft at the top and at the bottom called epimysium. All together, and shall realize that both shafts of the bone are separated by what we call a dimysium. It is the middle area of a bone. And you must also appreciate that in between the bone, we have what we call the spongy part and what we call the compact part. But those parts are actually protected by what we call the peritoneum. And you must appreciate the peritoneum, one of actually the examples of what we call the thoracic membranes in the body. As we see that the heart is protected by what we call the pericardium as a serous membrane, just the peritoneum protecting the scale, actually bones are together. So we shall see this now supplying blood to the compact part of the bone are together. We shall also see what we call the medulla canal, which contains of the yellow bone marrow. And shall see that this bone marrow helps the production of what we call the lymphocytes that help in actually defense and immunity. Also, this bone marrow helps in body cell formation. That is what I can also tell you about the structure of a bone. So, with that, I must appreciate that I shall always look at that. That is the structure, the general structure of a bone. So when someone tells you to display the structure, the general structure of a bone, you just draw and explain the functions of the different parts together. So allow me actually continue and actually look at what we call the development. I know before I reach at the development of bones, I must appreciate a bone has actually got cells. And these cells are actually 3 in number. That is what we call the osteoblasts. Osteoblasts. They are what we call the osteoclasts. That's what we call the osteocytes. There are 3 types of bone cells. Yeah, you must enjoy this topic. It's very easy and very simple for you. We have so answered the functions. We have also answered the types of bones and giving the examples. You have now also answered the general structure of a bone, because I told you it has got the epimysium, 2 epimysium at the top and the end, and under those epimysium we have what we call the red bone marrow in them. In between the spongy part under the dimysium, we have the compact bone, which consists of the different nerves that supply blood, and also it contains what we call the Medulla Canal. Those are 3 questions that I've answered. So now allow me to look at the structure of a long bone. But before we go to the structure of the long bone, we are still looking at the different body, actually the bone cells. So far, allow me to ask this question to you, and I want you guys to comment with the answers. How many types of cells you know? How many examples of cells under human being you know? Apart from red blood cells and white blood cells, and the osteoblasts, osteoclasts, and osteocytes. Those are 5 so far. There are many other types of cells in the body. So, if you understood issues properly, you must have seen like 5 types of cells. So, allow me actually talk about the osteoblasts as an examples of bony cells, and I will tell you that these are bone-forming cells. They are bone-forming cells that actually excrete, produce collagen and other components of bone tissues. You must have said that the osteoblasts later mature what we call the osteocytes. The osteoblasts will give rise to osteocytes, and you must have said that osteoblasts actually are present in the following areas: in the fracture sites, in the deep part of the peristoneum, which actually is a serous membrane over actually what we call the bones, and also present in the center of ossification. When you talk of ossification, the process of bone formation at the ends of the diaphysis, and also at near the epimysium. All together. So we shall realize that the osteoblasts give rise to osteocytes. They are found in what we call the fracture areas, peristoneum, the diaphysis, and epiphysis. They are also found in the centers of ossification, where bone bone development takes place. Having looked at the osteoblast, that gives the rise to what we call the osteocytes. So with the osteocytes, these mature. These are mature osteoblasts. These are mature osteoblasts. They are mature osteoblasts. And you must appreciate, as long bones actually develop, osteoblasts usually become trapped, and they stop forming new bones. And at this stage, we shall see the osteocytes being formed. And the tissue fluid in this region helps in the formation of the osteocytes. So, what is the major function of this osteocytes as a bone cell? They are responsible for movement of calcium between blood and bones. Are together? You must appreciate these ones are responsible for movement of calcium in between blood and cells. So, now we look at the last type of bone cell called the osteoclasts. And these are bone cells responsible for reabsorption and remodeling of a bone to maintain optimum shape. Are together? These ones, you can't have a fracture. The osteoclasts help in the remodeling, as you have had, the remodeling of the bone. Are together? They always help in the remodeling of that bone. Yeah. So, you must appreciate that the osteoclasts are majorly found in the following areas: under the sternum, to maintain the shape of the bones during growth, around the walls of the medulla canal. So the medulla canal is that area I actually showed you. The medulla canal is this area. That is the medulla canal. Have you seen the medulla canal? That is where you find what is the osteoclasts. Do you have people online? Yeah? Yeah. Okay. So, allow me continue. And I actually have discussed for you now. Because I told you we have three types of bone cells: the osteoblasts, osteocytes, and the osteoclasts. Osteoblasts give rise to osteocytes. Osteocytes give rise to osteoclasts. Yeah. So, allow me now to look at what we call the development of a bone. This is a wider topic. It needs time. Yeah. Excuse me. It needs time for you to actually understand these concepts. With the development of a bone, I'll actually put much emphasis. I'll put much emphasis on the different bone, actually, on the different stages contained in bone development. Are you together? So, you must appreciate that ossification is the process by which bones are formed. Are you together? So, ossification is a process of body formation. And you must also appreciate that the process of development of bones always actually starts at birth and actually takes place for only 21 years. Yeah, takes place for only 21 years. Allow me to tell you that actually, when you reach 21 years, you actually never grow. You don't actually grow any longer or short. So, the size you are on right now, if you clock 21 years, you will cease to actually grow long at all. So, the process of ossification, or what you call the movement of bones. So, when someone asks what is ossification? What is osteogenesis? It's the process of bone development. And I must appreciate that different bone types actually got different sources of development. For example, the long, short, irregular bones develop from what we call cartilage models. So, some can actually explain the different models through which bones develop from. The long, short, and irregular develop from what we call the cartilage models, and the flat bones that develop from what we call models. You must also appreciate that the different bones develop from what we call models. So, we have three types of models. We have what we call the cartilage model, the membrane model, and the tendon model. Those are the models through which bones actually develop from. It is actually a question that can be asked. Yeah. So, Allow me look at bone. Actually, allow me look at this. That bone formation actually consists of mainly two processes. We shall see two processes of the bone development. We shall see what we call the separation of what we call the osteoid by osteoblasts. With this, what we mean? We shall see the osteoblasts actually secreting or producing collagen fibers that will lead to formation of matrix, which actually represents the original cartilage model, hence the bone formation. The process 2 is what we call what we call calcification from calcium. And here we shall see calcification of the osteoid immediately after being deposited. The moment calcium is actually deposited, it will go through what we call calcification. So, with the development of bones, we shall see two processes taking place. What we call calcification and what we call separation of what we call osteoid by osteoblast. All right, together. So, allow me to proceed and actually look at the different actual arrangement of collagen in the osteoid as the processes take place. We shall see that we have what we call the non-layer bone, what we call the woven bone. That is an arrangement of osteoid during bone formation. We also have what we call the lamella. So, the woven bone, we shall see how the collagen fibers arranged in irregular bundles and then ossified. Now, under the lamella bone, here we shall see the collagen fibers have been deposited as within bones. So, that actually has been the introductory part. What you must know and bone development. You must know that the process within which bones are formed is what we call ossification. Actually, you must also appreciate that it's actually seen through different sources. That's what we call the cartilage model, that is the long, short, and irregular. The sesamoid model comes from what we call the tendon model, also the blood model, what we call the membrane model. Altogether, we also see two processes that in which bone formation take place. That is where we see the separation of the sesamoid, the osteoid, and also the calcification. Yeah, so allow me now to look at in general the deformment of a long bone. And I appreciate that it takes actually 4 stages. That is the fetal development at birth, during childhood and adolescence, and during adulthood. So, we have what we call fetal development at birth, childhood and adolescence, and also have what we call the adulthood. Those are the 4 stages of bone formation. Whenever someone asks, explain the stages of bone formation, you talk about the 4 stages. So, this is actually easier when actually it is seen in a actually using a diagram or a diagrammatically way. I must appreciate that the development of a bone is actually seen in a process called ossification. And these stages there are actually 4 stages involved in bone formation. And I must appreciate that during fetal development, now we are looking at the first stage. Within the cartilage model, we have used the model called the cartilage model. We shall see a long bone. Actually, there I shall see some small areas of osteogenic cells called centers of ossification. Actually, being the first and being the centers of primary centers of ossification. So, under fetal development, we shall see different centers of ossification being the primary centers of ossification. We shall see that the focal points of ossification begin, and this development actually takes around 8 to 48 weeks out of the 40 weeks. So, the development of a bone takes 40 weeks. So, among the first 8 weeks out of the 40, we shall see that the center or the focal points will develop. All together. So, later, immediately, it will be followed by what we call blood supply. And later, we shall see what we call bone tissues replacing the cartilage as osteoblasts continue to secrete osteoid into the bone shafts. Which shafts I talked of? The diamysium and the epimysium. The bone then lengthens as ossification actually continues and spreads into what we call the epiphysis. All together. Now, so with the first fetal stage, we shall see first of all development of the centers of ossification as primary centers. We shall see development of focal points between 8 weeks out of the 40 weeks. Now, later we shall see blood supply, and we shall also see the osteoblasts continuing producing what we call the osteoids. That is in summary of the fetal development. Now, at birth, you have been given birth to. Secondary centers of ossification will evolve into epiphysis. And then the Medulla Canal forms when the osteoblasts break down. All together. So, at birth, we shall see secondary centers of ossification are being produced, leading development of epimysium. Later, Medulla Canal forms, then the osteoblasts will break down. All together. Then, at birth, we look at the third stage. At birth, we shall appreciate that the bone will grow grows, and the length actually increases, of ossification increases. Are we together? We shall see the diamysium and the epimysium at birth. Are we together? Actually, around the birth, we have secondary. Now, after birth, so the first stage was fetal, where we see first ossification taking place. We saw focal points growing. We saw the development of blood supply. Second stage, we saw the birth. Second centers developing, also blast actually breaking down, and the Medulla Canal forming. Now, during during growth after birth, we shall see the epimysium and the diamysium enlarging in size up to the age of 21 years. And that can actually be seen diagrammatically. We can actually see that using a diagram. Yeah, this can be seen using a diagram. The fetal development is seen like this. Rods of cartilage are here. Primary center of ossification developed. We shall see the body collar also developing. We shall also see the diamysium dividing into the epimysium, both the epimysium being formed. So, look at this. Look at this. At birth, there was secondary ossification taking place. Blood supply taking place. After birth, we shall see elongation of the bone. Together, we shall see the bone elongating up to 21 years. Then the last stage is adulthood, where the bone longer grows when you are 21 years. Together. So that is all I can actually talk about with the development of bones. You must appreciate that bones, having seen the development of bones, that is all I can actually talk about the development of bones. Allow me actually look at the hormonal regulation of bone growth. And you must appreciate that the hormones actually play an important part in regulating bone development. We shall start they regulate bone growth. They regulate the consistency of the size or shape. These hormones are actually involved in the development of bones. And the following are seen. We shall see the growth hormones like the T3 and T4. We shall look at the testosterone and the oestrogen. We also look at the calcium. The calcium hormones in the body helping actually regulating bone growth. Are together. So under regulation of actually bone growth, we have actually seen what we call the testosterone and estrogen. That is the hormone that helps in bone growth. We have also seen another hormone called thyroxine. Actually, it is called thyroxine or triiodothyronine hormone. Actually, some of the hormones that help in regulation of hormonal regulations. Yeah. Allow me look at what we call the bony markings. When someone talks of bony markings, when I look at bony markings, these are various features actually found on bones. Yeah. And I must appreciate that these include the following. We are looking at bony markings. The neck has an enlarged, it is enlarged often around its head. That is the head of the bone. It's enlarged at its end. Okay, that is a bony marking. The neck has a constriction between the head and the body. The result always, as you look at this photo, there is a constriction altogether. That is what's called the neck. It has also got the margins, or the edges, which are protected by what we call, the edges are protected by what we call the peristernum altogether. So, it has also got what we call the angle, or the plane of a bone. Any angle of a bone is what we call a bony marking. It has also got what we call a process, which is actually prominent projection altogether. So, having looked at that, those are some of the bone actual markings we have, and we have very many other bony markings, including a hole in a bone. There's a word that actually talks about that. You must go and look at that. Allow me right now look at what we call skeleton. And you must appreciate skeleton is actually divided into two types. You have what we call the exoskeleton and what we call the appendicular skeleton. Yeah, you must appreciate that actually skeletal system is very easy. How does it work? Skeleton is something very easy. It is very easy to understand what we call the exoskeleton and what we call the appendicular skeleton, because there are two types of skeleton. When someone talks of what we call exoskeleton, you must appreciate that exoskeleton is the central part of the skeleton, consisting of the skull, vertebral column, ribs, and the sternum together. So, exoskeleton actually looks at the skull, looks at the vertebral column, looks at the ribs and the sternum, the upper parts, all together. So, while peninsular skeleton looks at the limbs, all together. So, what is the exoskeleton composed of? It's composed of the skull, called the cranium. And the skull has got different actually bones. It has got a parietal, temporal, occipital. Occipital is what we call encona in Uganda. Yeah? The sesamoid, the ethmoid, those are the bones containing of the skull. The face has got the maxilla, the palatal, the zygomatic, the mandible bone, the nasal, and so many other bones. We shall see the bones of the ear, or what we call the auditory canal. That is the inca, steps, and the malleus. There are three bones. Yeah. So have the base of the tongue, called the high pitch. So have what we call the rib cage with the sternum and the ribs. And we have what we call the vertebral column, which is divided into actually 5 regions. The cervical region, thoracic, lumbar, sacral, and the coccyx region. Therefore, the exoskeleton actually are composed of 60 bones. So, whatever I was talking of the scene, the structure of a skeleton. The scene of the structure of a skeleton. I told you the skeleton is divided into 2 types. That is the axo and the appendicular. Now, we're looking at axo. I told you the exoskeleton is consisting of what we call the skull. Are you together? Consists of what we call the sternum bone. This bone that divides the ribs. Just consists of what we call the ribs. Which ribs also part of the axo. So that the ribs are part of the axo, skull, the sternum, those are all part of the skeleton. Then the rest is called the appendicular skeleton. So always be careful. Exoskeleton, sternum, ribs are together, and the total number of bones there are 80. 506 bones. So the rest is the appendicular Are you together? So that is the skeleton, and that is the first part, actually called the axle, which is actually consisting of 80 bones. So our side is going to look at the structure of the skull, that is the cranial bone, and look at the different bones which it has. We shall say parietal, sesamoid, this is the structure of the skull. It has frontal, temporal, occipital, sesamoid, ethmoid, and so many other bones. And I just go to what we call the different bones. They also actually those are actually separated by what you call different spaces. Actually, it has got different spaces in between them. Called actually those spaces are actually given in them. It's a name called actually those are sutures. It depends on the area you come from. Sutures. It depends on the area you come from. So that is the scale. That is the skeleton. I also look at the occipital bone. Look at how they have broken down the different bones that make up the skull. The occipital looks like this. The occipital bone looks like this. Occipital bone. Are you together? Yeah, that's the occipital bone. And so many other bones that make up the skull. Allow me to tell you that the skull is made up of different areas. So as I told you, also the vertebral part of the medulla skeleton. So this is the vertebral column. The vertebral column divided into 5 regions. That is the cervical, thoracic, lumbar, sacrum, and the coccyx region. Yeah. Then later we shall see the ribs. We shall see the ribs. The ribs. This is the rib. We shall see this is the sternum bone. This is the rib. Sternum bone and the rib. Sternum and rib. Sternum is a flat bone. This is the rib. I have to get it also flat bone. Those are all part of the appendicular skeleton. That's the first part of the skeleton. Totaling to 80 bones. So allow me now look at what we call the appendicular. Now with the appendicular skeleton, that skeleton actually that consists of the rest of the parts apart from the vertebral column, the skull, the ribs, the sternum, the rest actually appendicular skeleton. You must have that the appendicular skeleton consists of the other types of bones. Those are the ribs, those are 126 bones. The two upper shoulder girdle and the two lower girdles. So that is with the skeleton. So you must always appreciate that those bones total to 160 bones. With the appendicular skeleton, I want to show you some of the examples of those bones. Well, remember, under the appendicular skeleton, always look at the upper limb. So we shall see the humerus, the tibula, the fibula, and so many other bones. So allow me to tell you that under the appendicular skeleton, we shall always look at the humerus bone. That is the humerus bone. We shall also look at the humerus bone. All together, the shoulder. The shoulder is the flat bone. We shall also look at the bones in the carpals. Shall look at the carpals. I shall also look at the bone near the buttocks, near the sacrum, and the femur itself under appendicular skeleton. And when you look at all bones totaling up to 126 bones. Today I didn't want to write much because actually these are very many bones that I cannot actually draw on a blackboard. So more is actually needed to you after having understood that bones are very easy and are very simple. Allow me actually look at a process of bone healing, and then we look at the joints and we call it a topic. Yeah, then it will be a simple. It will actually become a simpler topic. It will become a simpler topic by now. So allow me actually look at bone healing, and bone healing we shall see that that is where we shall see different fractures. And a fracture is also defined as a breakage on a bone. the breakage on a bone. And we have got actually measuring 3 types of fractures. Originally, you need to, now when you come to higher levels of learning, you'll get to see 3. A simple, where a bone actually breaks, but no blood is seen, or no protrusion from the skin. A compound where we shall see blood coming out and protrusion of the skin. And what we call the thyrogenic fracture, where the bone gets a fracture as a result of being weakened by disease like polio. All together. That is called what is called the thyrogenic. So, what are some of the stages seen under bone healing? After the breakage of a bone, hematoma forms between the broken end of the bone. Everything I explained will actually be seen diagrammatically. You must see this diagrammatically. Yeah, I must always show you this. Actually, after breakage of a bone, look at this. When you look at this, it will always show you what I'm looking at. After breakage of a bone, we shall see hematoma forming between the broken ends and in the near, or in what we call the nearby soft tissues. This is caused by inactive actual inflammation and accumulation of macrophages that will give microorganisms near the area. Alright, together. Then we shall see osteoblasts what will begin to form actually near the what we call the actually it's called a callus after 1/50 weeks, or what we call 1 week. The osteoclasts remain active at the center, and the bone allows mature or reuniting of the bone. That takes 3 weeks out of 52 weeks. After some time, or after some months, we shall see complete actually healing of the bone. What do we mean? So, allow me explain this properly. Look at this. We shall see hematoma forming out together, and the bone actually and the bone fragments coming together. After that, we shall see phagocytosis taking place out together. This is where we shall kill the microorganisms that will have attacked the place. The osteoblasts actually begin to form new bone. The osteoblasts will begin to form the new bone. Later, we shall see that the griddle spread, and actually we shall see how the bones to compact together. That is after 3 weeks. Later, with the time, we shall see the osteoblasts actually forming your bone. So a bone formation develops from 1, 2, 3, 4, 5 stages. All together. That is with the bone healing. So any breakage on a bone is seen under those stages. So for reference, visit your actually Ross and Wilson for clarity. Allow me right about now look at a joint. And a joint is actually a point or site where any 2 or more bones actually articulate or meet. Any place where 2 or more bones meet, if this is what this actually has made a joint now. Altogether, so we have got very many types of joints. We have what we call the fibrous joints or fixed joints, and under those joints we have what we call a joint between the skull. We have what we call joints of the upper teeth, joints of the lower teeth, and mandible. All together. Now we also have what we call the cartilaginous joints. Under these joints have the joints of the vertebral column, and also have what the joints of the pelvic region. All together. So those are some of the examples of joints. All types of joints have fibrous and cartilage. Actually, what we call the cartilaginous joints. Allow me also tell you that we also have what we call the synovial joints as a type of joints. Majorly have synovial, cartilaginous. Also have what we call the fibrous joints. Give examples of each. Fibrous joints, fixed joints. We have joint of the skull, of the upper mandible and the maxilla, upper mandible and the mandible. Also have the continuous joints, where we have the joint of the vertebral bones and also joints of the pelvic region. So with the synovial joints, it is where we shall discuss much, because actually it contains a lot of joints here. And by the time I finish these synovial joints, you must be able to actually answer any question that actually is found in a skeletal system. The first type of or example of a synovial joint is what's called a ball and socket, and this joint is found in the head. The ball and socket here is a joint here near the eye. Ball and socket, and it can be seen that it can actually allow movement of in the following way: flexation, extension, abduction, also retention, and also circumduction. That is those are some of the examples of movements that can actually be allowed by the ball and socket joint. So let us look at some of the examples of the ball and socket joints. We have what we call the shoulder joint and the hip joint. Yeah. And we also have now another type of joint called the hinge joint. And these are joints which allow movement of flexation and actual extension. You flex and also extend. Flex and extend. So examples, we have the elbow. Yeah, hinge, have the elbow. It allows flexation and extension. It has flexed and also extended. We have the knee. We have the ankle. Yeah, those are some of the examples of the hinge. We have the grinding joints. We have the carpals here. The tarsals near the ankles. The phalanges in this area. These are the phalanges. That is the grinding joint. Actually, these ones allow. These ones actually are found mainly in carpal joint bones. Allow me to look at the pivot joint. This allows movement of one axis or rotation. We have what we call examples include the proximal radial joints and the distal radial joints. Allow me also look at the saddle joints. And with the saddle joints, these are actually joints of movement that take place around the two ankles or allow flexation and extension. They are found in between the metacarpal and the metatarsal. All together. So there are some of the types of joints we have, the synovial joints. I talked about the ball and socket. Examples, shoulder and hip, hinge, we have the elbow, knee, and so whatsoever. Grinding, we have the carpal bones and the tarsal bones. The pivot, we have the proximal radial joints and the distal radial joints. And they also have what we call the saddle joints. We have the metatarsal and the metacarpal. Yeah. So that is with the synovial joints. With the structures, it requires you to go and actually look at actually the different structures. Allow you the different movements of joints. When I talk of flexing, it means blending forward. It is flexing. When I talk of extensing, becoming straight or blending backwards. When I talk of abduction, it means a movement away from the middle of the body. When I talk of rotation, rotating, you know, all of your rotation. When I talk of extension, actually extension means turning the sole of the paw of the foot outwards. Yeah, and so many other types of movements in joints. It's a question that is usually asked. Describe each of the following joints. You can tell you to describe the shoulder joint, knee joint, and so many other types of joint. And actually, one of the characteristics of synovial joints, it is that they actually articulate or actually have hymen cartilage. And you must appreciate that they also have what we call the capsule ligament. And some of the examples of synovial joints include this knee joint, which is actually a hinge joint. All together, it is a hinge joint. That is a knee joint. So you must also appreciate that we have very many types of joints, of synovial joints, and this actually shows different types of movements of different joints: the flexing, the extension, adduction, circumduction, rotation, and different other parts of rotation, actually movement of joints. That is all what I've explained to you. And with those, allow me with the skeletal system, actually stop at that and actually wish you the best. And I tell you that more in this topic is needed, and you must always put in a lot. Visit this book, visit the Ross and Wilson. You always understand things and enjoy life. Thank you for listening. Martin Imrondo is my name. You have been having skeletal system. Stay tuned. Always subscribe. Don't forget to subscribe to our YouTube channel called the Medical Discussions by Martin Imrondo. Also, always subscribe to actually also like our page called Medical Discussions by Martin Imrondo. Thank you for listening.